Oh my gosh, can you believe it? We're almost to the end of the book. We're entering in the last mod. We still have some other things that we can accomplish, and we might circle back to a few things so you're ready for the next year. But here's where we're at. So I need you to get your textbook and open to the beginning of Mod 13, which is on page 399. Get your pencil, make sure you have a calculator, and let's go. All right. This mod, we're going to talk about theoretical probability. Everything we did in Mod 12, we were doing with specific experiments. So we were actually doing something, recording what happened, use that for predictions. And this time now, we're going to talk about, in theory, what should happen. Okay? In theory, what should happen. So as we look at this first one, let's say you're at some sort of carnival or something, or the school fair, and apparently you have the chance to win an MP3 player, okay, or some sort of fancy electronic gadget that you've deemed you simply must have. So you have a choice of these two spinners, A or B. You win if the spinner lands on the spot that has the star designated on it. So it doesn't even matter the color, just the star. So let's take a look at figuring out which one really is the best bet. Total number of outcomes for spinner A. So it looks like 1, 2, 3, 4, 5, 6, 7. Looks like there's a total of 8 sections there, and 3 of them have stars. So when we figure out the probability, that total number of outcomes is the denominator. 3 out of 8 chance, which, grab your calculator, if we turn that into a percent, is 37.5%. Okay. I like turning it either into the decimal or the percent because then it's easier to compare and I don't have to deal with getting common denominator. All right, let's look at spinner B. Yikes. I'm going to have to mark these 1, 2, 3, 4, 5, 6, 7, 8. So it looks like 16, huh? 9, 10, 11, 12, 13, 14, 15. Yep, 16. Out of those, 1, 2, 3, 4, 5 of them have stars. Okay. And now when you take 5/16 and turn it into a decimal, which, by the way, if you went ahead and actually just took 3/8 and turned it into 16ths, you're going to see that this is a bigger value. But just for fun, I turned this into 31.25%. So when I compare these ratios, the ratio for spinner A is bigger than the ratio for spinner B. So I would choose A for a better chance of winning this game. All right. They're awfully close, definitely. But if you have to make that choice, definitely you want to choose the one that's going to have better chances for you to win. Okay. Theoretical probability now is the way to describe how you found the chance of winning this MP3 player in the scenario above. Using the spinner example to help you, explain in your own words how to find the theoretical probability. So what I need you to write here is just generically for any event, how you're going to describe it. You're going to start this way. Make a ratio, or in other words, a fraction, where the numerator is, this would be the actual outcomes that we're desiring, or the wins, if we want to talk about it that way, is the number of wins. And I'm going to put wins in quotation marks. Okay. And the denominator is the total possible outcomes. Denominator is a great word. Denominator. A lot of syllables. And the denominator is the total possible outcomes. I'm going to bump that up because I don't know where my face is hiding the screen. The total possible outcomes. There we go. Okay. So I honestly think most of you are very intuitive when it comes to this. Okay, so they called it the number of ways the event can occur. We called it the number of wins, okay? The specific thing that we are looking for over the total possible outcomes, all right? They run you through on the next page another possible scenario with marbles. I want you to jump down to question number 2 and number 3. And I would like you to pause the video, fill this out, and then come back in and check it. All right, here in the big box, they're actually looking for words to describe this. So the number of ways to roll a 3 or a 4, to roll a 3 or 4. I'm kind of messy, sorry. And this is the total numbers on that die. I say die instead of a number cube, all right? So you would get 2 out of 6, or 1/3 in simplest form. Number 3, how's the sample space? Sample space is the total numbers or the total possible outcomes. It is the denominator. Every time you make that fraction, now I'm messing up. After I was just bragging about what a great word it was, I definitely should use it more often. There you go. All right, let's keep plugging along here. Okay. 6 students are performing. You want to roll a die to determine the order that they go in. And maybe your teachers do this when you have to do a presentation or a speech or something like that as to who goes first. So in theory, okay, it says you roll the number cube once. The theoretical probability that a 1 shows up should be 1 out of 6. The probability that you roll a 2 is 1 out of 6. A 3 is 1 out of 6. A 4. Do you see the pattern here? Okay, we haven't actually done the experiment, but we know if it's a fair die, meaning it's not weighted so that one number pops up more frequently than the others, this is what should happen. Step 2, predict what should happen when you roll it 30 times. Since they're all equally likely, 1/6 times 30 happens to be equal to exactly 5. Which means if I roll it 30 times, in theory, what should happen is that you get exactly 30 rolls. That each one occurs 5 times exactly. Now, is that really going to happen? Probably not. But what I need you to do now is come on up to the front. You're going to actually get a die, and you have to do it you have to roll it 30 times and tally all across here. So come up to the front of the classroom, find that die, go back to your seat. You got to keep track of 30 tries and how many times it happens. Pause, do the experiment. All right, now everyone's going to have different answers here. So as you look at what you've done here, I need you to compare your experiment with theoretical. Okay, if you got exactly 5, 5, 5, 5, 5, 5, you can say they matched up exactly. If not, which is probably more likely the case, then tell me or analyze, describe what happened. Which numbers occurred more frequently than 5? Which ones were less? Was there a number that didn't happen at all? That'd be weird. Okay. By performing more trials, you tend to get experimental results that are more like or closer to the theoretical ones. So it says combine your table from step 3 with those of your classmates to make one table for the class. We are going to put this on hold, and we'll actually combine this together all at once in a little bit, okay? Once everyone has had the chance to complete step 3 and 4. Could they ever be exactly equal? Well, I would hope so eventually, but every experiment has a little bit of error. I shouldn't say error, but the reality of it is it probably isn't going to work out exactly equally all the time. All right, so here's what I want you to do. Starting on page 402 here, and as I'm looking at your textbook, I want you to start with these. Okay, you're going to with that guided practice on page 402. And then I want you to go through 16, which is on page 403. So 1 through 16. Have your calculator handy. Make sure you read the directions so that you know, do they want you to write your answer as a decimal, as a fraction in simplest form, as a percent, all three? You decide, or make sure you answer it properly depending on what they ask you. If you have the choice, then you can decide which way you want. All right. So page 402 and 403. And as always, good luck and may the force be with you.